Okay, so now this is the last lesson of this unit. Right, next class will be a review, and then we'll have a test on this. So now we with the calculator we were solving nonlinear systems. Now we're going to go back and say, okay, well then how would I solve them algebraically? Not by graphing them, but by using substitution or elimination to solve them. Okay, and the steps are pretty much the same steps. Right. Like for substitution, these are the same steps that we used before. The difference is that now we're dealing with squared terms, right? And sometimes if all the equations have x squared and y squared, they never have x to the first or y to the first. And you really don't need to be solving for x or y. You solve for the x squared or the y squared. So it's possible you're not solving for x, you're solving for x squared. That's a little different. And you know that we're going to get possibly, because when you cross a curved graph with a straight line or two curved graphs, you can get more than one intersection point. So you're going to get more than one answer. Okay, so here's a system. One is a quadratic and one's linear. In fact, you don't know it, or you may remember, I think in geometry, you go a little bit over a circle. The circle is x squared plus y squared equals r squared. That's a circle, right? That's a circle with a radius of the square root of 10. And, you know, how many places could a circle and a straight line, that's a terrible circle. So, how many places could a circle and a straight line intersect? You know, it could be 2, it could be 1, or it could be none. Okay, well, follow the steps. Solve one equation for one variable. Already done, right? Second step, substitute for that variable in the other equation. Right? So this will be x squared plus, in parentheses, negative 3x plus 10 squared equals 10. Okay, simplify. Okay, I need to FOIL the negative 3x plus 10. Right, so negative 3x squared would be 9x squared. Negative 3x times 10 plus negative 3x times 10 is negative 60x. And 10 times 10 is 100. Okay, combine negative 3x times 10 times negative 3x. Okay, when you FOIL negative 3x. Right, you have negative 3x times 10 and negative 3x times 10. So that's 2 times negative 3x times 10. Combine like terms. 10x squared minus 60x minus or plus 90. So because it's a quadratic, I could see it's a quadratic. I moved the 10 to the left-hand side because I know I want everything on the left equals 0. Okay, so now we have to solve that. What could we do to simplify that? Factor out of 10, right? Not even factor, divide out of 10. So if you divide the whole equation by 10, you're going to get x squared minus 6x plus 9 equals 0. And that's factorable. What is that? Yeah, it's x minus 3 squared equals 0. So what is x? X is 3. Okay, that's the end of step 2, right? Third step, substitute that answer back into the equation you solved on step 1. which we didn't actually solve because it was already solved for us, right? So we're going to take this and find our y value there, right? So I'm going to use a little function notation here. I'm going to say y of 3 equals negative 3 times 3 plus 10. So that equals negative 9 plus 10, which is 1. So this thing is intersecting at the point 3, 1. So it's only got one solution. It's a line. It's just a tangent line to the circle. So try to do the same thing with that. Okay, so you should have substituted here. FOILed. 2 x's cancel. 1 minus 10 is negative 9, so we've got a difference of squares, which factors, and the answers are 3 and negative 3. Right? That's the end of step 2. Okay, now you've got to plug these x values in here, right? Now when I plug in the 3, I get negative 4. That means I have the point 3, negative 4, right? They go together, right? It's not just going to be a list of x values and a list of y values. 3, comma, negative 4. And when I plug in negative 3, I get 2. So it's the point negative 3, 2. So these are the solutions, right? They're points. Okay. So eliminations. Now, when you solve that, again, these are the same steps. What I changed, I put in blue. It's what we did before. And that 0 step that I said, like, make sure your lines are in standard form. Well, standard form for quadratic equations like this is not quite the same standard form. And the truth is, it really doesn't matter if things are in standard form. I mean, you can always take 2 equations and add them up, even if you got the x's and the y's on opposite sides. As long as they are in both equations and something cancels, that's okay. So we're really not tied to that. They have to be in standard form. And it's certainly this standard form isn't going to look like the standard form that we did before. But we're still going to try to get terms to cancel when we add or subtract the equations. So now some of the terms are going to be actually squared terms. So you're going to have to get squared terms to cancel. And then you're going to get more than one answer, possibly. Okay. So for example, here's 2 quadratic equations. That is actually standard form. Standard form for these for conic sections are first you get the x squared term, then you get the y squared term, then you get the linear terms, x to the first and y to the first, then you get a constant, and it's all set equal to 0. So this in a way, this is standard form. But it doesn't make much difference. If I added these equations together right now, would it eliminate a variable? It would eliminate the y squareds, right? Now, what would have happened if I multiplied the second one by 9 so that I would make those terms cancel? Because you got this 90x, it's got a linear term there, you would have a problem, right? Because then you'd still have an x. You wouldn't have eliminated a variable, even if you eliminated the x squared terms. Most of these problems are set up that way, where there's going to be one variable that you can eliminate, and probably one that's got a linear term and you can't. But this one is set up for us to do what? Add or subtract. Right? That's an add. Because the y squareds are opposite, we're just going to add them. So we're going to get 10x squared minus, that's it, and it's actually the second equation is a 16, not a 1. I made this mistake last class. Okay, these cancel, and negative 90x plus 200. So that's just the result of adding them up. Okay, now let's divide everything by 10 because we can. And we get something that's factorable. So x minus 4 times x minus 5 equals 0. X equals 4. X equals 5. Okay, so there I've got the one variable solved. Okay, how do I find the second variable in elimination? I should go back to one of the original equations, and I think neither one is solved for a variable. So I'm going to solve this one for y. Right, I'll add y squared to both sides, and then I'll have y squared equals x squared minus 16. That means y equals plus or minus the square root of x squared minus 16. Remember, you can't take the square root of x and the square root of 16. It doesn't work that way. So that's my place to plug in for x, right? So first, when I plug in 4, y of 4, I'm going to get plus or minus the square root of 4 squared minus 16, which is what? So that's 0. So that's 1.40. And the second point, right, when I plug in, I'm going to get the square root of 5 squared minus 16, right? But that's plus or minus the square root of 9, right? 25 minus 16 is 9, which means that's plus or minus 3. So when I plugged in x equals 5, I actually got two y values, which means that's 2 points. That's the 0.53, and it's the 0.5 negative 3. So we could have up to 4 intersection points between two quadratics. This time we just had the 3. You'll learn probably in math now. First one is an ellipse. The second one is a hyperbola. Okay, so when I make my video, I'm gonna go back and fill in the next slide, which is a U-try, but I don't want to take the time because I want you to have more time in the quiz. And then I want to show you this next. So I was going to show you one other problem, and that's this one here. If we were going to solve by elimination here, it looks like we've got linear terms in x and y. How could we get one variable to cancel? Yeah, I mean, it would have to be constructed, just so, right? And it is, because if you multiply this one by 4 to make the y squareds cancel, then you're going to multiply that one by 4 and you're going to get 8y, and it is going to cancel too. So you will be able to cancel all of them in the same step. But that's what you're looking at when you're solving one of these by elimination. You got to get all the variable terms to cancel in some way. So I'll do those last two when I add them to the video. Right now I'm going to pause it. Right there. Okay, I've paused and I'm coming back to this. Students have left. We just didn't have time on this early close day to get through it quite as slowly as I wanted. Right, this was going to be the U-try, and if somebody's watching this video and wants to go through the U-try on their own, then by all means, pause the video now, and when you're ready, hit play again. Okay, this is a solve by elimination. We would like to be able to add or subtract these equations to eliminate a variable. So if I look, you might think you could eliminate x squares by subtracting the equations. But actually that's not true because you have a negative 16x out here. So the only variable you can eliminate now is y by adding the equations. So we'll get 2x squared minus 16x, and then we're going to have a negative 9 plus 39, which is plus 30, right? And it all equals 0. Okay, we can divide through by 2. And then that's a pretty simple factoring problem, hopefully. X minus 3 times x minus 5 equals 0, and which means x equals 3 and x equals 5. Okay, now we've got to find the y, and because we didn't actually solve either one of these equations, well, I guess we never do an elimination anyway, so we got to go back up to one of these and find y. And I think pretty clearly we'd want to use this one. And if I solve this for y, I'm going to get y squared equals x squared minus 9. Take the square root of both sides. Y equals plus or minus the square root of x squared minus 9. Okay, now I plug in x equals 3, y of 3, plus or minus the square root of 3 squared minus 3. 3 squared minus 9. That's going to be 0. That gives us 1 point, 3, 0. And now we've got to plug in 5. Y of 5 equals the square root of 5 squared minus 9, which is the square root of 16, which is 4. Actually, sorry, which will be plus or minus 4. So that's 2 more points. 5, 4, and 5, negative 4. So this was a circle and a hyperbola, right? Something like, hyperbola is something like that. And a circle, obviously, you know what a circle is. So it must have been something like that maybe it did something like this. Crossed in 2 places, and then 1 place on the other branch of the hyperbola. And then the last one I was going to show you is this one. If you notice in this system of equations, there's actually x, a linear term in x and a linear term in y. So it may look like we have issues with how are we going to get all the variables to cancel. But the truth is this problem has been fairly carefully constructed so that it would. I mean, if I'm going to cancel y squared, that means I would have to multiply this by 4. But when I multiply that by 4, I'm going to get 4 times 2y, 8y. So when I subtract the equations, I'll be canceling all the y terms at the same time. So let me rewrite this system. It's x squared plus 4y squared plus 4x plus 8y equals 8. And now it's 4y squared. Look, I'm just going to write it right here. 4y squared minus 4x plus 8y equals 20. Right? Multiply all these terms by 4. Okay, now in order to make these two cancel, I have to subtract. So let me subtract the second equation from the first. X squared. Okay, these cancel. 4x minus negative 4x is plus 8x. Don't let them cancel. The 8y's cancel. And this equals 8 minus 20 is negative 12. So x squared plus 8x plus 12 equals 0. And that's hopefully an easy factor. X plus 2 times x plus 6 equals 0. So x equals negative 2 and negative 6. Okay, now we've got to figure out how are we going to find y by plugging that in. And that actually could be a bit of a challenge here. So let's see. If I plug in for x in this equation, I'm going to have two y terms, okay? That's probably the best we can do. So let me do that. I'm going to write down this original equation, y squared minus x plus 2y equals 5.
Chris Elliott, please report to the Commons. Chris Elliott to the Commons. Thank you.
Okay, for y equals negative 2, right? Then I'm going to get y squared plus 2 plus 2y equals 5. Or y squared plus 2y minus 3 equals 0. So we have y plus 3 and y minus 1 equals 0. So here's the y coordinates, or just y values. Y equals negative 3 and y equals positive 1. I'm going to extend the page down here. Okay, so that gave us the points negative 2, negative 3, and negative 2, 1. Okay, that's just for the x equals negative 2. Okay, now we've got to do the same thing. We've got to do the same thing for negative 6. So I'm going to move it down here. Y squared plus 6 plus 2y equals 5. So page extender, y squared plus 2y, and this will be plus 1 equals 0. So this factors as y plus 1 squared equals 0. So y equals negative 1. And so for x equals negative 6, we just get one value of y, so it's negative 6 comma negative 1. So all together, right, all together, these are the solutions. And that's it. That's the end of our treatment of systems of equations. And that is the homework.